Hello good people, welcome back to my channel. We are still continuing with the layout, and today we are talking about the run-out or exit table found in the dishwash area. Remember, we designed the entry sink, which is the pre-rinse sink. The dishwasher is at the middle. Today we are going to talk about the run-out table. The run-out table looks like this, more or less just like the sink. The only difference is that it doesn't have a bowl, and the profile is on the opposite side. Remember, this profile on the sink, it was on this side, then on the run-out table it's gonna be on this other side. These are the dimensions. The overall size of the sink is 1500 by 750, and the height as usual is 860, and it has some storage where you can keep the crates with the plates for them to dry up before you store them in their final position, the four-tier rack or shelves, wherever you want to store them, right? And this varies with the design of the dishwash, or rather the crates, the size of the crates. For this case, I will be using a crate which is about 515, just around there. So I gave it a space of 520 for there to be some allowance for the crate to slide in without being tight, right? And the height is 125. This, as I am saying, will be determined by the size of the crate, and if you want, you can have two partitions where you can store your crates, but hey, these are things that you can do them as you wish. Now, without further ado, let us go ahead and do the design. Open Solidworks, new, then go to part, click OK, and go to the top plane and do your new sketch. The sketch is center rectangle. This dimension is 1500 by 750. Click OK. Do another line. Do a line here. Why is one line there? Select, then another line here. This is for the purposes of giving the sketch that you will be working with some relationships. Now this, between this and that, should be 350. Right, as you can see right here. Where is it? No, it's 135, sorry, 135, and it's not from where I'm trying to put it. So let me delete this and change it. This and this, 150. This and this should be 15 millimeter. Exit the sketch, and that will be for the purposes of dimensioning the other sketch. Now go to plane, reference geometry, plane, offset it to whatever dimension you want. There is no harm. Right click, select the sketch, the plane, and start a new sketch. Normal, go to center rectangle, don't snap it at the middle. Dimension from this side to this should be 50, and this side and the front should be 50. Right click, exit dimension, then this line and this line should be collinear, and this line and this line, make them collinear also. Now, as you can see, this is where we have that profile that will be hooked on the dishwasher machine, and this part will have the profile just like the sink. Right, so with that having been done, you go to sheet metal and choose base flange. Thickness of the material is 1.5. Right click, the other parameters keep the same. Hide this plane. Then edge flange here should go on the upper side, and the end condition blind. And condition blind, size is 50mm exit. Now create a tab on this side, on this face, and should be on this side, corner rectangle. Snap it on that edge, select this line and this line, make them collinear. This point and this point, make them vertical. I hope now this line, I hope it is vertical with this. Yeah, it is vertical. Or is it that let me see, I just don't want to make a mistake. Let me see whether it can make them coincident. Yeah, that is good. Then exit the sketch, merge result, click OK there. Now create an edge flange on this side and this side, degree at 30, and condition blind, size 20mm. Click OK. Now go to corners and choose the close corner, choose butt type, the opening 0.1mm, that is okay. Select that corner, right click, your edge is good. Create edge flange again, that direction and this direction and this one, and make it parallel to this face. Right, exit the sketch, choose edit the sketch, this line and this line, make them collinear, and automatically it will adjust also this other edge flange. Right, closed corner again, you choose this face. I don't want to choose the next, actually I deleted the face that I wanted, this face and this face. Right click, there you have your closed corner. Now create edge flange. Alternatively, you can do a mitre sketch and do all this flange at one go. Right, this, make it 50 and condition, right click. Then here is the profile where you're going to be hooking it to the dishwash sink. So you create an edge flange there which is 20mm by size, and that's okay. Then create the other edge flanges, the two edge flanges that are remaining on this side and this other side, and condition blind, size 15mm. There you have it, your top is taking shape. Now create an edge flange here at the back. Right click, select this face and edit the sketch. Choose this line and this line, and to make them collinear. I hope they are collinear. Exit the sketch, then create an edge flange for the upstand, and this is 50mm also. Exit, make an edge flange on this face, right click, choose the face, edit the sketch, choose this line, and at the last line, shift, then choose that line, make them collinear. Yes, there we have it. Your edge flange is good. In no way will your table be, this is 10mm. In no way will your table be bigger than whatever you wanted, right? Remember, you wanted a table of 1500 by 750. So if you do that sketch of the overall dimensions, then you give your edges, the sketch of the edges, you give them relationship basing them on the initial sketch. It's not gonna be big, right? The size will remain the same, and I feel like our top is good, so we can go ahead and save. I do have a folder in the layout that I call DW dishwash area. Then there is the runout table. Part number 1, I would call it DW runout table top. Save. Now the legs are the same. The legs are the same as of the sink, but we are creating the legs, and open the top plane, start a new sketch, center rectangle, dimension it at 40 by 40. In fact, let me choose this line and this line, and I make them equal. Then I dimension this to 40mm. Then I can offset my sketch by 1.5. That is the thickness of the square tube, and reverse direction, that's okay. Then I go to feature, extrude direction, I choose mid plane, and the size it is 830. If you had your grommet, you will get a height of 860. Then I go ahead and save this as part number 2. DW RT legs. Right. No. We go ahead and start our assembly. Reason being, I want to know the size of the bracing, and that I will do after I evaluate what is the distance from. So we met this leg with the top. I think there is something that I'm not doing here, which is very important. Let me first evaluate and get the measurement from here to this face here. The normal distance is 586.5, so I can create I go to file, new, I create a backing channel there, because you don't want to do your welding of the leg directly to the top of the table. center rectangle. I really cannot remember. 586 is the size, so I can do 580, 585, 554. 554 by the size of the channel will be, we want 40 in there, 15, 50, 40 plus 30, that is 70. We can do 72, 72. That's right. Then sheet metal, base flange. This channel, backing channel, can be whatever size. These things are normally determined by the size of the offcut that you have. Sorry, I'm supposed to do an edge flange. Edge flange here, edge flange here. This can be of 45 or even that. Let me do 40. These things are not to worry you. The size of the channel should not worry you so much. I create an edge flange here and an edge flange here of, and condition blind 15mm. Right click and go ahead and save this as backing channel. Part number 3, EWTR backing short channel. So I go back to my assembly and insert that channel. Insert components. Component to insert is the channel, this channel. Then I rotate it. That's good. Now I can start my matting. This face should mate with this face. That's right. And this face should mate with this face. That's good. Then I want to see whether 40 is big. Then I will go to advanced mate and take width. So I will take this face, then the other face is this one. Sometimes it's good to choose faces that are near each other, so that when you're doing rotation you don't rotate twice, right? But make sure you know what you're doing, man. There you go. Our channel is set. It's not protruding under here, and yeah, that's good. Yes, we can go ahead and mate this, the top of the leg to the channel. No. I shouldn't have done that. Let me first edit this channel and make it, we had made it 40. 40 looks a little bit big, so let me edit it to 35. This edge flange here, I edit this to something like 35mm. Save the changes, go back to the assembly. Yeah, this is good. Remember, you're going to stick your channel to the top using a macroplast, and you can do some little welding here and there, but make sure your welding doesn't show up on the top. Now mate, yes, this face to this edge of this bend. That's good. And this face, did I choose this face to the top of the channel? That's good. Now let me do advanced met. We shall see whether, and do width. We shall see whether it will fit correctly between the channel. That face, then this face, and this face. That's correct. That's actually good. Yes. Now let me mirror some component, and I'm going to mirror this component against the right plane of the channel. Mirror components, component to mirror is the league. That's good. Now I want to, let me evaluate, measure from here to here. That should be 1503. Okay, so I want to do some linear component so that I may create the legs. Simply linear component on that direction, the opposite direction. This is 2 numbers, and the distance should be 1500 minus 15 millimeter here, 15 and like 20 millimeters, so it's 1500 minus 35. That should be 1465. Components to linear, this component and this component. I didn't subtract 40, I didn't subtract 20, so let me subtract 20 millimeter. Oops, sorry, minus, actually it should be 40. Yeah, you don't want, you want there to be at least 20 millimeter gap, at least 20 millimeter gap. Between this edge and the legs, so that you know your table might hook completely to the table, to the sink, and that is bigger because of this channel, because of the backing channel. So the backing, let me subtract again, like 50 millimeter. We see what happens. 50 is way too big. Actually, from there I should have subtracted 20, but let me add 30. Yes, at least 20 millimeter and we are good. So our sink is good. Let me evaluate again and measure from here to here. Evaluate, normal distance is 476, so let me do a bracing of 476. File, new part. Okay, then I go to the right plane, sketch, new sketch, center rectangle, select this line and this line and make them equal. Size is 25 millimeter. You can do a bracing of 25, 30 depending on what offcut you have, right? Most of the times we use whatever we have in the workshop, okay? Because this is just a bracing. But again, you also consider the fact that you need strength. What did we say the distance was again? Mid plane 5, I can't remember. 5, let me do 535. I will edit, can't remember. Save it as part number 4, DWRT short bracing. I go back to my assembly and insert component. Component to insert is the short bracing. I rotate it, then I met. The first met should be which one? Surely the first met should be this face with this face. That's okay. Then I do width. No, let me do distance, and distance I do 150 from this bottom and this. Can I change direction? Yes, that's okay. Then I do advanced met, and I do width, and it's between this face and this face. Then this face, oopsie, this face and this face. Did I choose the face too? This is what I was telling you about. Just make sure you know what you're doing as you choose the faces. This face here, this face, then that face and this face, then on the upper side this face. Yes. Yeah, and my bracing is good. Let me evaluate and see what was this distance. This distance to this face should have been what? 476. Now let me evaluate also for the long bracing. The long bracing should be 1365. Okay, so I go back to my bracing and edit this to 476. Then I save changes, create a new part, right plane again, sketch, dimension. Alternatively, you can save as the short bracing, you can save it as, and make the necessary changes. Make this line and this, we make them equal, and the dimension here is 25 mil. Then I offset by 1.2 in the opposite direction, the reverse direction. That's good. Then I go to feature, extrude, mid plane 1365. Hope I'm right this time around. And this we save it as part number 5, DWRT long bracing. Good. So with that done, we go to our sketch, and what is not happening here, our assembly, sorry, and insert component, long bracing. That is good. Met component, this face and this face, then this face and this face. Then we go to width, advanced width, this, then this, then what did we choose? This and this. Yes, We are good. We are very good. Now, with that, do we need to mirror? Yes. I will go ahead. Let me collapse this. Then I open which one? Let me collapse this also. Collapse this. Then I can go to short bracing, right plane, linear component, mirror component, component to mirror is this one. Right click, okay. Then I collapse that. I go to long bracing, right plane, mirror components, component to mirror is short bracing. Right click, and the bracing is done. Okay. Now let us evaluate and know the spacer, the tube that we require. What should be the size from here to here? What is the height? 680. So we need a square tube of 25 by 25. I go to file, new, drawing part. I go to top plane, sketch, center rectangle, then again different ways of doing these things. This line and this line, I make them equal. This line and this line, I make them equal. Then I smart dimension this to 25 mil. Then I take this and do it 1.2. There we go. Oh. Do you know I have forgotten the size of this? This should be what? I really have forgotten. Let me do 700. I will edit again. I think I should be having a rough piece of paper where I should be writing these things, because I really am forgetting very fast. Let's go back to the assembly. And the assembly met component. No, we shouldn't. How can we met something that we have not inserted first? We didn't even hey, what's going on? I didn't save it. But now that I'm in the assembly, let me evaluate again, and we are looking for that height, 680. I was close, right? I was a little bit close. Let me edit this to 680. 680. Right click. Let me save it. Part number 6, DWRT. What do we call this? Partition. And save it however way you want, whichever makes you happy and whatever is easy for you. So insert component, simply insert component, partition is the component, and mate component, this face, to this, right click, then this face to this, right click, then here we do distance of 520, sorry, between this and this. That's good. Now let me go and edit mirror component 1. I edit it and I will choose this. That's good. I just added that. Okay, now we want to know what is the size of the railing channel, that the rail angle line, this for sliding 556 for where the crates will be sliding. Okay, 556. So we go to new sketch, part, click OK, top plane, sketch, center rectangle. The size is 556. 556. Let us do 555 by 30 mil. That's okay. This should be 1.5 because of the weight of the crate and the dishes that you have washed. Okay, this should be 25, edge flange 25, right click, then you do what? Then you fillet. You avoid sharp corners, and the fillet should be of 3 mil. Just give it a small radius. You know, these are the things that you do with a grinder and a flap disc, right? I hope you guys, you normally use, what do you normally use for polishing? I'm saving it as part number 7 and calling it DWRT rail. Okay. You know, in the advanced countries, I really don't know how you do your polishing. Ours is absolutely manual. We are mating this face to this. You know, you find some guy with that grinder, which we normally call that street grinder, and here we have given it a name as an AK-47 because it is very big. It's way too big, right? So we call it AK-47. That's good. Let me bring another. Let me insert another so that I may rotate it accordingly, and also so that I may do what I shouldn't have rotated it on the X direction, the Y, so that I may do the linear component, mate component. Yes, this face to this face. Right click, this face to this face, right click, then this to this, right click. Now I think the size is not correct. Oi. Yeah, I shouldn't have taken that size. I should have evaluated it from here to here, and that should be 540. So let me open this part and edit the sketch to 540. Base flange, edit sketch, 540. And I think that is good now. Save. We go back to our assembly. Now let us do linear component. Linear component, that direction, reverse it. We need 5 of them. The size is 125. 125. Components to linear. It is this, sorry, this and this. And your table is set. your table is done. Now the other thing that is remaining is to insert the comments and all that, and your table is done. Now let me see if I insert browse, then I go to layout and DW pre-rinsing. Here is my sink. Yes. Reviewed. Let me see. Yes. See now here. Let me just do some little matting here and there. Therefore I will take this to this, right? I want them to be on the same level. Now that being done, I can, okay, let me take this and this. That's good. Then I can create just some small distance for the dishwasher. Yes, just like that. Now what will happen is this part, this is the entry part. It is hooked on the dishwasher. Your utensils, there is the receiving table. Can we open the layout? Yes, there is the receiving table. Here is the opening for the window from the restaurant. The utensils, the dishes are, the dirty dishes are coming from the restaurant through this window. Then there's the receiving table, then to the pre-rinsing, to the dishwash, and to the run-out table, right? Now let us go to our assembly. Where is that assembly? Right here. So the arrangement basically is like this. Yeah, it's only that if you can remember what I have just shown you on that layout. So the receiving table is somewhere here. The restaurant is somewhere here. From the restaurant receiving table, then they scoop the dirt under the chute to the dustbin. Then they pre-wash, because this is called a pre-rinsing. They pre-wash the dirty plates. You having a single bowl, a double bowl, there is no harm. Remember the pre-rinse tap. You can swing it to whatever bowl you want. Then from there you slide. There is a crate here. You arrange your utensils on the crate. You slide it into the dishwashing machine. Let the dishwasher do its work. Once it is done, the crate, you slide it to the receiving table, to the run-out table. Then you store your utensils here, and after storing them there, you can take them to the storage racks. These are the storage 4-tier racks, right? I hope you understand what we are talking about, but I will make sure that layout, I will give it to you in a SketchUp format, and also I will try my best to take all these items and place them in a Solidworks layout, so that you may understand how these things are happening. So thanks so much for your time. We'll see each other in our next tutorial. I'm sorry I've been a little bit busy. That is why I've taken a lot of time to upload. Actually, I wasn't around. I traveled from where I stayed to go and attend to some other business, but now I'm back. I will try much as I can to finish up with this layout so that we may get into other things. All right, thank you so much. Continue subscribing. If you can see, the channel is really growing, and that is all thanks to you guys. See you in our next video.